This is a video of OCR FP3 January 2007 question 6, a differential equation question. Now the question asks us first to find the complementary function for the following differential equation. Now we've got dy dx plus 3y equals 2x plus 1. Now, it's a little unusual in that you'd normally be expected to be finding complementary functions and general solutions and particular integrals and so on in second-order differential equations in FP3, and a lot of the first order you're solving by the other techniques, but the same techniques apply for these first-order equations as well, and we're just going to use the same thing. So the first thing we're going to find is our auxiliary equation. And in a second order differential equation, you'd start with lambda squared or some such for the d2y dx2. There's no d2y dx2, so we're just starting with lambda here for the 1 lot of dy dx plus 3 for the 3y equals 0. And that obviously gives us a solution of lambda equals minus 3. Now that then lets us write down our complementary function is going to be a e to the minus 3x. We've only got a single solution, so there's no need for a b, e, or anything like that. It's just a complementary function there of a e to the minus 3x. Now, the second part of this problem asked us then to find the general solution from this. Now, for the general solution, we're going to need to deal with the right-hand side of our differential equation. We're going to need a trial function and find a particular integral. Now, this is linear. It's 2x plus 1, so our trial function for this is going to be ax plus b. Now we're going to need a dy dx, but no d2y dx2. So dy dx of that is simply a, just differentiate that, and that's what you get. Now I'm going to substitute this back into our original left-hand side here and see what we get. So the dy dx is a plus 3 lots of y. It's going to get us 3ax plus 3b. And we know when we substitute that back in, we need to get the right-hand side out. We need the 2x plus 1 out of the other side of our equation. And now, comparing coefficients here, I can see straight away that 3a has got to equal 2, and that means a has got to be 2/3. Then, comparing with the 1 there, that tells me that 2/3 for that a plus 3b has got to equal 1. So 3b is going to be a third, and b is going to be a ninth. Let's move the page up a bit. And so I can then write out my particular integral there. So my particular integral is going to be 2/3 x plus a ninth, and my full general solution then, is going to be y equals a e to the minus 3x plus 2/3 x plus a ninth. Right, so that's part 2 done. We've got our general solution. Now, the next question they ask us, they give us a particular case so that we can actually find that constant a there. And in their particular case, they say dy dx equals 0 when x equals 0. So let's find dy dx. We have to differentiate this. We get dy dx equals the derivative of this term here is going to be minus 3a e to the minus 3x. It's a function of a function. Derivative of minus 3x is minus 3 multiplied by the derivative of e to the something, and remember you differentiate e to the anything, you just leave it alone. So derivative of that, minus 3a e to the minus 3x. Derivative of this is simply 2/3, and derivative of the ninth is 0. So this is our dy dx. Now, we know that's equal to 0 when x is 0. So I can say 0 equals minus 3a. Now, when I put x equals 0 into here, I've got e to the 0, which is just 1. So I've got minus 3a plus 2/3. Rearrange this, I've got 3a equals 2/3, and a equals 2/9. And so that's going to give me my final particular solution. It's going to be y equals 2/9 e to the minus 3x plus 2/3 x plus 1/9. Just take that a, put it back into the general solution. And then the last part of this question asked us what happens when, we'll write down a function to which y approximates when x is large and positive. Well, we'll have a look back at this function here. When x is very large and positive, this e to the minus 3x is going to tend to 0 as x tends to infinity. So we can begin to ignore this term as x gets larger and larger. But this stays put. That's just 2/3 x plus 1/9. So the function it approximates to as x gets large and positive is y equals 2/3 x plus 1/9. If you were to sketch it, you'd find it tending to this straight line as an asymptote, but that's FP2, not FP3. And that's the question solved. Thank you.